Okay guys, welcome to our next lecture. So just to recap, in the last lab we did advanced logic gates. We studied latching circuits, and I also gave an oil pump and motor assignment, so make sure that you have submitted that. In this lab we will be studying timers. So let's say you're creating a process and you have to run something for X seconds, or something is running and you want to stop it after Y seconds. So for example, let's say washing machine, clothes dryers, conveyor belts, launch sequence events. For example, if you're launching a missile or a rocket, so you need timers for these types of things. So back in the day, uh, these electromechanical devices would be used for timers, and obviously they were quite expensive to manufacture, and they are also quite complex to use. um, Now we have the PLC. So the PLC basically has timers built in, and we can simply use them for our processes. uh, there are two main types of timers: the on delay and off delay timers. I will explain this in detail after a minute. Um, so timers basically, just like you have your inputs with x0, x1, outputs with y0, y1, timers are indicated by t0, t1, t2, and so on. And the number of timers depends on the PLC which you are using. Most PLCs allow you to use a few thousand timers at least, so it should not be an issue if you need to use lots of timers. So let's take a look at an example first, and then we can see how they work. Let's say that I want to turn on an output after X seconds. So let's say I have a fan, and I press a switch, and I want the fan to run 5 seconds after pressing that switch. So let's actually design this first. This would be an example of an on delay timer, because I turn on my switch and there is a delay, an on delay, and then my output turns on. So I'll make a new project. I'll call this timer. Make sure simulator is clicked. I'll click OK. And in the instruction toolbox, at the very bottom, you have timer/counter/drum. So click this and you'll see many different options. You should see off delay and on delay. We are working with the on delay timer first, so I'll click and drag this over here, my first network, and you should get this screen. Now I will explain this graph after a while. Let's just see how it works. Over here I can set the delay time, so that would basically be how many seconds. So let's set this to 5 seconds for now, and you can simply press enter, and now we have a timer. I will just add a switch over here, so I'll drag a normally open contact. Let's call this X0, and if you can see here, the timer is giving me an output C0. So I'll drag another input, and I'll call this C0. So what's happening is that after 5 seconds, C0 will be high, and I can use that to trigger my output. So I'll call this Y0, and now let's see what's happening. So I'll accept the changes, and now what we will expect to see is that when I turn X0 on, my timer will start to count from 0 to 5 seconds. After 5 seconds, C0, which is the output, will be high, and therefore my output should turn on. So I'll go on PLC connect. I'll connect my simulator, and I will write this program to the PLC. And I will also put on status. So if you click this simulator, you can also see the timer in real time. So this is my simulator. So what I expect to see So I'll put this in run mode. What I expect to see is that once I press X0, the timer will start, count to 5, and then turn on my output. So I'll turn on this switch, and you can see it's in timing mode, it's counting, and the output is off. And after 5 seconds, C0, the output is on, and the done flag is true. And this timer will continue to count until and unless you switch this off again. So if I switch this, if I click this, the timer will restart. I'll click it again, and again C0 is off. After 5 seconds it will turn on. So let's take a look at the graph. So I'll drag another on delay timer, and in this case, for this graph example, they have used C0 for the input and C10 for the output, but the idea remains the same. So your output is initially off, so you can see this is off over here, and C0, which is the input signal to the timer, is also off. As soon as this signal is high, so this is my input signal C0, as soon as this is high, the timer will start to count, and in this case the on delay is 1 second. So I give a signal, the timer counts to 1 second, and after 1 second my output is high, so it goes from off to on over here. And you can see that the timer continues to count until I turn the input back off. So in that case, at the top there was an input over here, X0, and when I switch that off, my timer would go back to 0. So the same is happening here. If I turn this off, this timer will reset back to 0 and my output is 0. And then again I can turn the switch back on, my timer will count, and my output will remain high after the threshold of 1 second is reached. And you can change that threshold over here. You can specify milliseconds, seconds, minutes, or hours. So that is basically how the on delay timer works. Now I will turn this simulator back off. Let's take a look at off delay timers. So I'll click the timer, I'll delete this, and I'll put an off delay timer. So over here I'll just specify a 5-second off delay, and I'll click OK. Now for off delay timer we will be using a normally closed contact, and I will explain why in just a second. And here we have T1 and C1, so I will change this to C1. I'll accept the changes and I'll write the code. I'll click OK and make sure the PLC is off. Now the way the off delay timer works is that initially you give the timer a signal. So in this case my switch is off, which means that my timer initially has a signal. As soon as you detach this signal, or if you open this signal so that there's no power flow, as soon as this signal is lost, the timer will start to count from the initial value to 0. So it works in the opposite way. Initially you give the timer a signal, so initially it's connected, I'm getting power. As soon as I open this signal, contact is lost and the timer will count to 0. And initially you can see here that the output is on, and if this output is on, that means Y0 will be on. And as soon as this counts to 0 seconds, this will be off, and my time, and after 5 seconds my output will be off. So I'll run the code, and you can see here that as soon as I press X0, this contact is lost, my timer is counting down, and after 5 seconds my output turns off. So I've explained that over here, that maintains contact states when the coil is energized but starts timing after the coil is de-energized. So initially this coil is energized, but as soon as I press this X0 button, the coil is de-energized and counting begins. That is basically how a off delay timer works. So I could set this to, let's say, 60 seconds, and I'll write this code, and let's say I have a washing machine, and the washing machine needs to run for 60 seconds initially, and after 60 seconds it should turn off. So what would happen is, as soon as I turn this switch off, sorry, as soon as I turn this switch off, the timer will count down, and after 60 seconds this output will be disconnected and my output will be off. So you can see that in the slides here. I've explained how it works, and it's quite simple. So here you can see the same process for on delay and off delay. Now you have a task with timers, and that basically uses your old example. So the previous lab, I gave an oil pump and motor program, and if you remember, I stated that first the pump should be on, and only when the pump is on the motor should begin. And for that you would simply do something like, if I make a new file here, you would do something like, let's say this is your pump. If this is on, then you would turn on your motor. But now the question says, add a timer that causes the motor to turn on X seconds after the pump is turned on. So now, instead of this being direct, you would have to connect this to some timer, and then use that timer to connect the motor. And the second part of the task is, when the motor is turned on, it should turn off again after Y seconds. So what would happen is that the motor is on initially, but after some time it turns off again. So X and Y, I believe, are the digits of your roll number. So X is the last digit of your roll number, and Y is the, let's keep this as second last digit. So let's say, for example, your roll number is 1745125. So that would mean that Y is 2 and X is 5. So that's it for this lab. I will make a task for this on Google Classrooms, and you will have to submit that by next week.